In our last lesson, we introduced the concept of concentration and molarity and looked at how we can calculate molarity based on the amount of solute that we dissolve into a particular solution. So the more solute you have, the higher the molarity is going to be. In this video, we're essentially going to be looking at what happens if you vary the amount of solvent instead. So what we're going to be talking about is a concept known as dilution, which is lowering the concentration of a solution by adding additional solvent. If we think about what we know about molarity, we said that molarity is moles of solute per liter of solution. And we think a little bit about just how math works. If we increase the amount of volume that our solution is taking up without adding any more solute, so same amount of solute present, all we're doing is adding more water. If we increase that volume, we're increasing the denominator of this fraction, of this ratio of moles to volume that we have. If we're increasing this volume that's on the bottom of our fraction, that means our molarity is going to decrease, that the value of this fraction overall is going to decrease as our denominator gets larger. What is also going to be true is if we are not changing the amount of moles, the number of moles, if we multiply both sides by the volume in liters, that will cancel this out, and we will have the molarity times the volume over here. So as long as we're not adding or removing solute, the molarity times the volume equals the moles, and the amount of moles is going to remain constant if all you're doing is adding water. So if that number of moles is constant, what that means is that the molarity times the volume at some point in time is going to be equal to the molarity times the volume at any other point in time, if all we have changed is the amount of water in the system. So generally, this is considered to be before dilution. So the molarity times the volume before the dilution is going to be equal to the molarity times the volume after the dilution. Since we know that molarity times volume is moles and the moles are staying constant throughout a dilution process, this relationship is going to be true. And this allows us to do all sorts of calculations relatively easily when you are dealing with a dilution type situation. And dilution is another common way that we make solutions in the lab. Depending on what you have available, you may have a highly concentrated solution of the substance that you need. It is a lot easier to just dilute it down to the concentration that you want rather than going and getting the pure solute and dissolving it into water. Or you may not even have that available as an option. For instance, when we are working with acids in the lab, we buy all of our acids as concentrated solutions because most acids are either gases or liquids by themselves. So it's a lot harder to deal with those as pure substances. So we buy them already dissolved, but we buy them at a very high concentration, and then I dilute it down to whatever it is that you need for the lab that we're actually doing. So dilution is another powerful tool for making solutions at the quantity and concentration that you're looking for when you're doing an experiment. So let's look at a couple examples of dilution calculations. So first up, if 75 milliliters of 0.5 molar sodium chloride are diluted to a final volume of 500 milliliters, what is the new molarity? So anytime you are dealing with a dilution, you are going to be using this relationship of M1V1 equals M2V2. And we want to sort of take stock of what do I know and what am I solving for. So my initial molarity before I dilute it is that 0.5 molar. I'm told I have a 0.5 molar sodium chloride solution that I am diluting. Its initial volume is 75 milliliters. So I'm taking that 75 milliliters of my 0.5 molar solution, and I am diluting it up to a final volume of 500 milliliters. And we are asked to determine what will the new molarity be. So we're going to want to solve for M2, and we can do that by just dividing both sides by V2. So we will have M2 is equal to M1V1 over V2. And once we recognize all of that, it's just a matter of plugging in the information that we were given. So M2 is going to be equal to M1 was 0.5 molar, V1 was 75 milliliters, and V2 was 500 milliliters. So the only thing that's that you kind of have to pay attention to is making sure that you keep the right molarity and volume like together, that your ones both represent the same point in time, that before dilution I started with this volume at this concentration. After dilution I ended up with this volume at this concentration. So this is going to end up giving us a concentration of 0.075 molar. So after the dilution, we would have this as our M2. Stick with my same color. Go. So one thing to notice here is that I didn't convert these to liters, and it doesn't matter. Because it ends up being a volume ratio, as long as your volumes are in the same unit, it doesn't matter what that unit is. This volume is going to cancel this volume, so as long as they're both in milliliters or both in liters, heck, they could both be in gallons or fluid ounces, it literally doesn't matter as long as both of your volume units are the same. So in this case, our milliliters canceled out, left us in units of molarity, which is exactly what we were solving for. One more example to take a look at is, again, kind of a more real-world application. Usually you have a target in mind of what is the thing that you want to create. In this case, we are looking to create 100 milliliters of this 0.0002 molar concentration after our dilution. Before our dilution, we are starting at 0.02 molar, and we are looking for what volume do we need. So again, we're going to be using that same relationship, M1V1 equals M2V2. Our initial molarity before dilution was 0.02 molar. So this was our M1. Our initial volume is the thing that we're solving for here. So that is our end goal, is to find what volume do I need to start with and ultimately dilute to get my final solution. The molarity I'm looking to end up with is this. Oops. Consistency. And the volume I'm looking to end up with is 100 milliliters. So same idea, we're just solving for a different variable here. I wrote a 1 where I should have written a 2. Apologies. Gosh, and now my colors are messed up. E2, M2. There we go. All right, so same idea, just solving for a different variable. We're solving for V1 here. So we can divide both sides by M1. So we will get V1 is equal to M2 times V2 over M1. And then we can plug in everything that we know to find that volume. So the value for M2 was this 0.0002 molar. My final volume was 100 milliliters. Started out at a concentration of 0.02 molar. In this case, we can see our molarity units are canceling out, and we're ending up in units of milliliters, which is fine. I don't specify a unit that I want your answer in. Any unit is good. And we end up getting 1 milliliter for our final answer here. So what this is telling you is if you have a 0.02 molar solution available to you, and you want to end up with 100 milliliters of a 0.0002 molar solution, you need to take 1 milliliter of your starting stuff and dilute it up to that final volume of 100 milliliters in order to create that solution.